This will be for the con exercise, add vectors, magnitude, and direction. So they give us two vectors on the graph here with the magnitude and the angles. And they want us to find the magnitude and direction of v plus w. So we're adding the two vectors. Okay, the final answer is rounded to the nearest tenth. Intermediate calculations to the nearest hundredth is okay. And this would be the sum of the magnitudes, and this would be the angle. So there's a few steps here. All right, first step, we're going to add the x components, and then we're going to add the y components, and then we're going to use Pythagorean theorem to find the magnitude. That'll be this answer here. And then we're going to use the inverse tan function for the angle or direction, and that'll be this answer here. So I made a little table here of the two vectors and the x and y components. Okay, you don't necessarily have to do it this way. I'm just showing you. Remember, to find the x component, we use the cosine function. Okay, so for vector w, the magnitude is 7, and that's going to be multiplied times the cosine of the angle for vector w, which is 50 degrees. See this angle right here? That's for this vector. So that's going to be 7 cosine of 50. And for vector v, same thing. We see the magnitude of vector v is 4. And that's going to be multiplied by the cosine of the angle for vector v, that is this angle right here. So that's 310. Now you do the same thing for the y components, but instead of using cosine, you use the sine function. So it's going to be the same thing, except you replace cosine with sine. Now, I'm going to add these together on the calculator and put the sum here. Remember, they said we could use the round to the nearest hundredth for the intermediate calculation. So I'm going to round off to 2 decimals in both cases here. Okay, on the calculator, I did 7 cosine of 50 plus 4 cosine of 310, and I got 7.07. And adding 7 sine of 50 plus 4 sine of 310, I got 2.30. Okay, of course, make sure you're set to degrees. So for the resultant vector, we're just going to use Pythagorean theorem. Okay, the x component is 7.07. The y component is 2.30. Okay, don't worry about positive or negative, because for the Pythagorean theorem, we're just going to square it. Okay, and this line here in pink is going to be our vector, or the hypotenuse. Okay, so the x and y components make a right angle. Across from your right angle is your hypotenuse. I'll just call it C. And we're going to use Pythagorean theorem. A squared plus b squared equals c squared. Okay, so we have 2.3 squared. Let me do this in black so you can see it. 2.3 squared plus 7.07 squared equals c squared. Okay, solving for c, you just take the square root of both sides. And I'm going to do this on the calculator and round to the nearest tenth. and I get 7.4. So that is going to be the magnitude when you add these two vectors together. And that goes in the first box. Okay, and you don't necessarily have to draw this triangle to do your calculation. It's just going to be Pythagorean theorem every time. Square the x's, square the sum of the x's, square the sum of the y's, add them and take the square root. So in the first box here, just enter 7.4, and now we're going to find the angle or direction. So you can see here from the x and y components, if we went about 7 units on the x and 2.3 units on the y, the resultant vector would be here. Okay, that's in the first quadrant. So we know the answer should be between 0 and 90 degrees. If you remember from the previous exercise, the formula is basically the inverse tan of y divided by x. Alright, that's for the angle theta. So we're just doing the inverse tan of y, which is 2.30, divided by x, which is 7.07. Okay, I'm going to do this on the calculator. Make sure you are in degrees. Okay, rounding to the nearest tenth, I get 18.0 degrees. That is between 0 and 90. So the answer makes sense, and you just enter that in this box here. Now, please don't forget for this final step here with the angle or direction, you may need to add 360 or add or subtract 180 from the answer that you get. That's why you want to draw a sketch and see which quadrant you are in based on the x and y components of the resultant vector. Alright, one more. This time I won't use the table. Okay, so I'm going to do the sum. This is a Greek letter sigma. The sum of the x components. The first one for the vector w, the magnitude is 3. And the angle for w is 70 degrees, so it's going to be cosine of 70 degrees. And then for the other vector, the magnitude is 7. And the angle for that one is this right here. That's 310, so it's going to be the cosine of 310. Alright, I'll do the calculation in a moment. And then for the sum of the y components, it's the exact same thing except you replace cosine with sine. So it's going to be 3 times the sine of 70 plus 7 times the sine of 310. Okay, so I'll do this first one on the calculator. They said the intermediate calculations can be nearest hundredth, so that's 2 decimals. Okay, rounding off, I get 5.53. And by the way, on some calculators, you can just type 3 cosine of 70. Occasionally, you might have to type 3 times cosine of 70, but that's the same thing. Okay, for the y's, I get negative 2.54. So let's enter the answers. Whoops, I forgot Pythagorean theorem. Okay, a squared plus b squared equals c squared. The x component is 5.53. The y component is negative 2.54. But really, you don't need to worry about the negative at this point because you're going to square it anyway. Okay, and the resultant vector is going to be the hypotenuse c. So that's what we have here. So 5.53 squared and 2.54 squared. I just ignored the negative because it's squared, and that equals c squared. Solving for c, we take the square root of both sides. Okay, I get c equals 6.1. That's the magnitude when you add these two vectors, so you enter that in the first box. So for the direction, you want to see which quadrant you're in based on these. Okay, I'm going to go positive 5.5 on the x, and I'm going to go negative 2.54 on the y. So that would be down since it's negative, and this right here would be the resultant vector. Okay, so we're in quadrant number 4. Alright, so the formula is inverse tan of the y, which is negative 2.54, divided by x, which is 5.53. Okay, do this on the calculator in degrees. And rounding off, I get negative 24.7. So that's going to be this angle here. Okay, and it's negative because they measured it going this way. Alright, now it didn't say in the write-up that the answer has to be between 0 and 360, but I'm pretty sure it does. Let me just try the negative answer and see if they take it. Okay, so in the box, I'm going to type negative 24.7, and let's see what happens here. Okay, so they do accept it. Alright, so I suppose negative answers are okay. Really, if they said between 0 and 360, you would have to add this answer to 360. And you would get 335.3. So this also would have been an acceptable answer, because 335.3 would have been measuring it this way around. Okay, that's really the typical way you do it. But like I said, be careful. Okay, just real quick, I'll show you. If you're on the graph, like so, and you have a vector like this, okay, the one angle for the vector on this side, if you do the inverse tan, the one for this angle right here is going to be the same for the one for this angle right here. Okay, so you have to find out which quadrant you're in at the very end, and you may have to add or subtract 180 from your answer when you do the inverse tan.